There are parts about probability that are really difficult to learn in a short period of time, and what we're about to venture in here into is something that could be very dangerous. It's easy to misunderstand it, and part of the problem comes in the way that we as probability folks have written down our symbols. This is the formula that could cause us some problems. It says the probability of A and B occurring is equal to the probability of A times the probability of B occurring given that A has occurred. And I think it's unfortunate that we use this intersection sign. We should really be putting the word and in there. And has two different meanings. If we select only one thing, in the world of probability and statistics, if you see n is equal to 1, we selected one thing, n equals 2, we selected two things or whatever. When we only select one thing, the word and means intersection. I would argue that in that case, this is the correct symbol to use. So here's an example when n is 1. We're going to select one person. What's the probability that someone that has low self-esteem, let's say that that's A, and they're a Boy Scout, so that's B. Well, to find the intersection of that, it's just these 80 kids. These are the kids that are both low self-esteemers and they're Boy Scouts. So we go to the intersection of those two things. We looked at that before. That's really easy. So we just get the answer as being 80 out of 200. But now, if we now go to the idea that we're selecting two things, we're going to select with replacement. We'll pick one, we'll record what it is, we'll put them back, and then we'll pick another one. So we're selecting with replacement. Now I would argue that this is a lousy sign to be using. We shouldn't use an intersection sign. We should read this as and. And when we select two or more things, and no longer means intersection, it means multiply. And that's the best application of this rule. I'd rather we said that this was and define the probability of, in this case, getting two things. The first one being someone with low self-esteem, then we return them into the pile, reselected, and the next one was a Boy Scout. Well, here's what we do. We find that probably the first person selected had low self-esteem. That's this 90 out of 100. So that was 90 people out of 100 had low self-esteem. Then we'd multiply that by the probability we get a Boy Scout on the second choice, and there's 100 Boy Scouts left out of 200. So we'd get our probability that way. So this formula could be a little bit ugly, but the thing I want you to take away from this right now, if you select one thing, the word and means intersection. If you select two things, the word and means to multiply. That's really a better understanding as we go forward. So let's try to use this rule, but let's use it in this case. We got marbles. We got 7 red marbles and 3 blue marbles. We're going to randomly select 2 different marbles. Now, when we're selecting more than one thing, if you see the word different, it implies we're selecting without replacement. So we're going to select 2 different marbles, find the probability that they are both red. Well, now, if we're going to use this formula, we're going to say we want to find the probability that we get a red marble and then we get another red marble, but we're selecting without replacement. So we first take the probability that we get a red marble, which that's 7 out of 10. There's a total of 10 marbles altogether. So that's going to be 7 out of 10, and then we need to turn around and get another red marble, but because we selected without replacement, they had to be different marbles. Now there's only 6 red marbles left out of a total of 9. So now the probability that our next marble is red is 6 out of 9, and that's how we're going to get our probability right there. Now, by the way, sometimes I can't help myself. I have to tell a joke whenever I get a chance. And why? Because I lost my marbles. Okay, let's go to the next screen. All right, so here, now, this is where it could be kind of confusing. We use a Venn diagram when we're only going to select one thing. So know when to say Venn, and this time we're only going to select one thing. Well, now, let's suppose we want to find the probability of getting A and B. So if we're selecting one thing, the word and means intersection. So let's go find the probability of selecting one thing, and that thing is in the intersection of A and B. It's both part of A and it's part of B. Well, we don't need this stinking formula right here. We don't want to use that formula. We just want to go over here and say, look, in the intersection we see 7 things out of a total of 20 things. We're done. We have our answer. If we're looking for the probability of an intersection of A and B, let's try to avoid that ugly formula if we can, and let's get this answer right here. Now, just to show you that this formula does work, let's go ahead and one time let's use it. Let's find the probability of A and B occurring simultaneously when you select one thing. We can get that probability by taking the probability of A, so the probability of A occurring times the probability of B occurring given that A has occurred. Well, the probability that A occurs, that's two regions. That's 12 out of the 20. So we're going to take 12 out of 20, and we're going to multiply it by the probability of B occurring given that A has occurred. So if you knew A has occurred, you would shrink your sample space down to just that. A has occurred. And the probability that B has occurred, knowing that you're in A, is 7 out of 12. So we would multiply this by 7 out of 12. There, we used our formula to find the intersection. And look what happens. We can cross-cancel this with this. And we're left with 7/20. So my point would be, why would you want to use that ugly formula, in this case for intersection, when you know you can just go find the probability of the intersection right there? Okay, so hopefully that makes sense, that we could use that formula for intersection, but that formula is better used when this is and we're selecting two or more things. So let's look at this situation, and let's try to make the, stay with me, because I would love it if we could really understand what's going on here and not just get lost in some of these formulas. So let's suppose we have some convention and there's politicians and there's lawyers present, and we want to find the probability of selecting one person who is a politician and a lawyer. So now, because we selected one thing, then what we're trying to find is the probability of a politician and a lawyer. Because n is 1, this does mean intersection. So the easiest thing to do is just go over here and say, oh, okay, let's go find the intersection of a politician and a lawyer. And it's right here. It's these four people out of, well, there's 90 here and there's 70 here. So there's a total of 160 altogether. So our probability is just the intersection. It's 4 out of 160. We're done. Let's not use that ugly formula. Oh, but you know what? Let's go ahead and use the ugly formula just one time to show us how goofy it really is that we would use this formula. If this was intersection, we could say, okay, let's take the probability that we get a politician. That's 90 people out of the 160. And let's multiply that by the probability that we get a lawyer, given that it's a politician. So if we knew that we had a politician, out of those 90 people, what's the probability we get a lawyer? Well, that's 4. So that's 4 out of the 90. Oh, look at that. We could cross-cancel the 90s and we're left with 4 out of 160. But why would you want to use that formula if you're just finding the intersection? Because when selecting one thing, and just means you're finding the intersection. So just go find the 4 people in the intersection on 160 and be done with it. But now, what if we do this? What if we're going to find the probability of selecting 2 people with replacement? We're going to replace them this time. The first one being a politician and the second one being a lawyer. That's when this formula is pretty darn handy to us. We would multiply. The word and means that we should multiply. So I'd rather this said and instead of intersection. Okay, so what's probably the first person's a politician? Well, that would be 90 out of 160. And the probability that the next person is a lawyer, given that we selected a politician, well, because we're dealing with replacement here, we're putting the politician back in, so we still have our 160 people all together. So what's the probability that the next person is a lawyer? Well, we've got, let's see, 10 lawyers out of 160, so we would multiply this by this. There, that's how we'd get our probability of first getting a politician and then getting a lawyer. So that's a good formula for that. All right, now, here's an ugly one. What if we did the same problem, but we did it without replacement? Well, the probability the first person was a politician would still be 90 out of 160, but now you'd have to multiply it by the probability of getting a lawyer, getting that a politician was taken, but we wouldn't know if the politician taken was a lawyer or not a lawyer, so this problem gets to be pretty ugly. And the good news is, in your classes right now, unless your teacher is really grumpy, you're not going to be doing a problem without replacement from a two-way table, so we can toss that out the window. So the thing you really want to come away with is this. I would really rather that we read this as the word and. The intersection sign should really be read as the word and. And if we are selecting one thing in a Venn diagram, then the word and means intersection. So it does mean intersection when we select one thing. So it's just the 7 people out of 20, the 7 people in the intersection out of 20, and you're done with it. It's better to use this formula typically when you're selecting 2 or more things. When you're selecting 2 or more things, then the word and implies that you should multiply. And then this guy comes in pretty handy right here. So again, the probability we got a red marble was 7 out of 10. Then we multiplied that by the probability of getting another red marble, given that a red marble had already been selected. So it became 6 out of 9. So there you go. If you can keep those things straight, the word and has different meanings depending on whether you select one thing or 2 or more. And we have one last ugly problem to do, and that's a disease type problem on the next video.